Hello everyone. Today in this lecture I am going to discuss the object oriented software engineering and UML, how it is used in the engineering and how the unified modeling language is used. I am Sunil Kumar Vishwakarma, working as an assistant professor, School of Engineering, BVD University, Lucknow. So, first of all, what is UML? What is Unified Modeling Language? So, UML is a language for modeling software systems. So, UML, we can say UML is used for modeling software systems. UML stands for the Unified Modeling Language. UML was created by the Object Management Group. UML 1.0 specification draft was proposed to the Object Management Group in January 1997. UML is not a programming language. It's not a methodology to develop software systems. UML provides tools that can be used to generate code in various languages using UML diagrams. It is also used to model non-software systems as well. For example, the process flow in a manufacturing unit, the process flow in any science area. UML uses mostly graphical notations to express the design of software. UML is independent of particular programming language and development processes. So UML is independent of any particular programming language. It encourages the growth of object-oriented tools. So these are the introduction to UML. So we can say that Unified Modeling Language is a general purpose developmental modeling language in the field of software engineering, and that is intended to provide a standard way to visualize the design of a system. Okay. UML offers a way to visualize a system's architectural blueprint in a diagram, including elements such as any activities, individual components of the system, how the system will run, how the entities will run, how the entities will interact with others, what are the external user interfaces. So these are the design concerns, design elements which will be used in the UML. Now, the importance of UML modeling. The first importance is a model may be structural, emphasizing the organization of the system, or it may be behavioral, emphasizing the dynamics of the system. A model provides template for building systems to help in visualize. We build models so that we can better understand the system we are developing. We build models of complex systems because we cannot comprehend such a system in its entirety. A good model includes those elements that have broad effect and omits those minor elements that are not relevant to the given level of abstraction. So we can say that the UML is a standard language for specifying, visualizing, constructing and documenting the artifacts of software system, as well as for business modeling and other non-software systems. Okay. So what is model? A model is a simplification of reality, providing blueprints of a system, and it permits you to specify the structure or behavior of a system. Okay. Or we can say that UML is a very powerful tool that can greatly improve the quality of your system analysis, the quality of system design, and it is hoped that the improved practices will translate into higher quality systems. So by using UML iteratively in analysis and design, you can achieve a greater understanding between the business team and the IT team regarding the system requirements and the processes that need to occur in the system to meet those requirements. The first iteration of analysis should be a very high level to identify the overall objectives of the system and validate the requirements through use case analysis. So identifying the actors and defining the initial use case model are part of the first iteration. Subsequent iterations of analysis further refine the system requirements through the development of use case scenarios, class diagrams, sequence diagrams, state chart diagrams, and so on. And each iteration takes a successively more detailed look at the design of the system until the things are relationships in the system are clearly and precisely defined in UML documents. Okay. What is the principle of modeling? The mainly four principles of modeling, such as the choice of what models to create has a profound influence on how a problem is attacked and how a solution is shaped. Okay, so every model may be expressed at different levels of precision. The best model are connected to reality. No single model is sufficient. Every non-trivial system is best approached. What do you mean by non-trivial? Non-trivial means significant, having some variables or terms that are not equal to 0 or an identity. Means significant. So every non-trivial system is best approached through a small set of nearly independent models. So this is the development rules of UML. Object-oriented methodologies. So object-oriented methodologies. What are the methods? So we can say that object-oriented methodology is a new system development approach which encourage and facilitate the reuse of software components. It employs international standard unified modeling language from the object management group. Using this methodology, using this object-oriented methodology, a system can be developed on a component basis, which enables the effective reuse of existing components, and it facilitates the sharing of its other system components. And another is object-oriented methodology asks the analyst to determine what the objects of the system are, what responsibilities and relationships an object has to do with the other objects, and how they behave over time. Okay, so there are several object-oriented methodologies. The first is Rambach Object Modeling Technique, OMT. It was one of the first object-oriented methodologies, and it was introduced by Rambach in 1991. And object modeling techniques uses three different models that are combined in a way that is analogous to the older structured methodologies. Which three models object modeling technique uses? Object model, dynamic model, and the functional model. So where these models are used, after gathering the requirement, there is analysis process, and after analyzing the requirements, there are three models: object model, dynamic model, and functional model. And using these models, the system is designed, object design phase, and after that coding is done. Okay, so this is object modeling techniques. What we do in the analysis phase, the main goal of the analysis is to build models of the world. The requirements of the users, developers, and the managers provide the information needed to develop the initial problem statement. Okay. And what is the use of object model in this object modeling technique? It depicts the objects, classes, and their relationships as a class diagram, which represents the static structure of the system. It observes all the objects as static and does not pay any attention to the dynamic nature. The second model is the dynamic model. It captures the behavior of the system over time and flow control and events in the event trace diagrams and state transition diagrams. Okay. The third is functional model. It describes the data transformations of the system, and it also describes the flow of data and the changes that occur to the data throughout the system. The second is Code Jordan Object-Oriented Analysis and Design. So this is known as the second generation methodology. How it works is consists of three main processes: initiating, developing, and deploying. It determines high level requirements, the scope of the system, and the resources that will be required. In developing phase, it involves the detailed analysis, design, and implementation of the system. And in deploying phase, it introduces the system to the user and subsequent maintenance of the system. Okay. So what are the objectives of the object-oriented methodologies? These are the third is Booch object-oriented design, and fourth one is Saller-Miller. So what are the objectives? Objective is to encourage greater reuse, to produce a more detailed specification of the system constraints, to have fewer problems with validation. These are the objectives. What are the benefits of the object-oriented methodologies? It represents the problem domain because it is easier to produce and understand the design. It allows changes more easily. It provides nice structures for thinking, for abstracting, and leads to modular design. Simplicity. This methodology is simple because the software objects model complexity is reduced and the program structure is very clear. Reusability. It is a desired goal of all development process. It consists both data and functions which act on data. It makes easy to reuse the code in a new system. Messages provide a predefined interface to an object's data and functionality. Increased quality, maintainable, scalable, modularity, modifiability, client-server architecture. These are the benefits of object-oriented methodologies. Now, the next topic is object-oriented modeling. Object-oriented modeling, how it is different from old approach? So there are two perspectives. One is algorithmic perspective and other is object-oriented perspective. So how it is different from one another? Algorithm perspective, it is an algorithmic approach which takes building block as collection of functions. But in object-oriented perspective, it is an object-oriented approach which takes building blocks as collection of data and functions as one unit. Another difference is algorithmic perspective. In this approach increases the complexity of the project along with duration. In object-oriented perspective, this approach decreases the complexity of the project along with duration. So with increase the time, the complexity is reduced in the object-oriented perspective. Okay. Third is transition of phases is not easy in this approach. Transition between phases is easy in the object-oriented approach. Basic unit here is function and basic unit here is object or classes. So object-oriented modeling is an approach to modeling an application that is used at the beginning of the software life cycle when using an object-oriented approach to software development. So the software life cycle is typically divided into several stages, going from abstract descriptions of the problem design, then coding, testing, and finally the deployment. So modeling is done at the beginning of the process. Okay. So object-oriented modeling is typically done via use cases and abstract definitions of the most systems. The most common language used to do object-oriented modeling is Object Management Groups Unified Modeling Language, UML, which we are going to see. in the coming slides. Okay. Now, what are the processes of object-oriented modeling? What do you mean by process? Anything in execution is known as process. So processes of object-oriented modeling passes through the following phases: object-oriented system analysis, after that system design, object design, object-oriented programming. So these are the phases through which it is processed. And this is the conceptual model of UML. So UML is divided into different categories. Its modeling is divided into different categories: building blocks, rules, and common mechanism. Further, building blocks are divided into categories: things, relationships, and the diagrams. Things are further classified into structural things, behavioral things, grouping things, annotational things. Further, structural things are divided into classes, interfaces, collaborations, use cases, component, node. These are the building blocks of the UML model. Behavioral things: interaction diagrams, state machine diagrams, states. And grouping things are the packages, and the annotational things are the nodes. What about relationships? There are 4 types of relationships are possible in UML: association, dependency, generalization, and realization. So, how you will differentiate these things? Association in UML. Association is a relationship between classifiers which is used to show the instances of classifiers that could be either linked to each other or combined logically or physically into some aggregation. So UML specification categorizes association as semantic relationship. Okay. Now the dependency relationship in UML. A dependency is a relationship that shows that an element or set of elements requires other model elements for their specification or implementation. The element is dependent upon the independent element called the supplier. Okay. The third is generalization. What do you mean by generalization? A generalization is a binary taxonomic that is related to the classification. Directed relationship between a more general classifier, that is superclass, and a more specific classifier, that is subclass. Okay. So because of this, generalization relationship, also informally called is a relationship. So this is the third relationship. Now the realization relationship. in UML. In UML modeling, a realization relationship is a relationship between two model elements in which one model element realizes the behavior that the other model element specifies. So these are the relationship of the building blocks of the UML model. There are various diagrams in the UML. So first is class diagram. A class diagram in UML is a type of static structure diagram that describes the structure of a system by showing the system's classes. By showing the system's classes, by showing their attributes, their operations, and the relationships among the objects. Now the second is object diagram. Object diagram in the unified modeling language is a diagram that shows a complete or partial view of the structure of a modeled system at a specific time. The third is use case diagram. A use case diagram can summarize the details of your system's users, and these users is known as actors, and their interaction with the system. And to build one, you will use a set of specialized symbols and the connectors. Next is the sequence diagram. A sequence diagram shows object interactions arranged in time sequence. It shows the objects and classes involved in the scenario and the sequence of messages exchanged between these objects needed to carry out the functionality of the scenario. So sequence diagrams are sometimes called event diagrams or event scenarios. Next is collaboration diagram. So collaboration diagrams are used to show how objects interact to perform the behavior of a particular use case or a part of use case. So this is known as collaboration diagram. The next is state chart diagram. A state chart diagram is one of the 5 UML diagrams used to model the dynamic nature of a system. They define different states of an object during its lifetime, and these states are changed by events. So state chart diagrams are useful to model the reactive systems. Okay. Now the activity diagram. Activity diagrams are graphical representations of workflows of stepwise activities and actions with support for choice, iteration, and concurrency. Now the last one is deployment diagram. A deployment diagram in the unified modeling language models the physical deployment of artifacts on nodes. To describe a website, for example, a deployment diagram would show what hardware component exists, what software components run on each node, and how the different pieces are connected. So this is the deployment diagram. Okay, so there are rules. Rules are further classified into names, scope, visibility, integrity, execution, and after that common mechanism, specification, adornments, common divisions, extensibility mechanism, and these are further classified stereotypes, tagged values, and constraints. So this is the conceptual model of unified modeling language. Now the building blocks of UML. Conceptual model of UML. The building blocks of UML. What do you mean by building block? The building blocks of UML contains three types of elements: things, relationship, and diagrams. The unified modeling language is a general purpose modeling language in the field of software engineering, which is designed to provide a standard way to visualize the design of a system. Basically, the building block consists of three components: things, relationship, and diagrams. Things in UML. This is the important part in UML building block. Things can be classified as a structural thing, behavioral, grouping, and annotation things. So what is structural? Structural things define the static part of the model, means a stable part of the model. And structural things are class, interface, collaboration, use case, component, and node. Classes are set of objectives which give similar responsibilities. Interfaces are set of operations which specify set of classes. Collaborations define connections between elements. Use case describes set of actions performed in a system. Components describe the physical part of the system. So this is the structural things. These are the mostly static parts of the model, representing elements that are either conceptual or physical. So there are 7 structural things in UML. They are class. So classes are, a class is a collection of similar objects having similar attributes, behaviors, relationships, and semantics. Graphically, class is represented as a rectangle with 3 compartments: class name, attributes, and the operations. Thank you.